Today, guys, we're going to talk about the 3 ways we can determine if triangles are similar. You can see their titles at the top. You can use 2 angles called angle, all 3 sides known as side, or doing what I call a side angle side sandwich. And I'll explain that last one here momentarily. So the first one, the angles, we can say that 2 triangles are similar if that in both triangles, at least 2 angles are exactly the same. So for example, in this first one they gave us a 75 and a 75, and they also gave us a 31 and a 31. So I've got 2 sets of identical or congruent angles. So that means these triangles are similar. It is going to matter how I name them though. Order is going to matter. We have to match in order. So for example, if I wanted to call the first triangle ABC, right? And I want to say it's similar to the other triangle, I have to pay attention to what I did. I went from A, which had the 75, then I went to the angle that had nothing. Then I ended with 31. I have to follow that pattern. I have to start with 75, go to the angle that had nothing, and then end with 31. So I have to name the second triangle DEF. If I wanted to call this first one, because there's more than one way to do it, it's just order matters when we start. So, for example, let's say we wanted to call it triangle CBA, because we can do that. I have to follow that pattern. So if I call it triangle CBA, I started with the 31, went to the none, ended with 75. Have to do that same pattern. Have to start with the 31, which is F, go to the angle with no label, and end with 35, which is D. Both statements are correct. It doesn't matter. You could do it also, BAC, and then it'd have to be angle EDF. All up to you. So naming the first triangle is not what's important. It's really following the pattern for the second one. And we're going to keep practicing this. In number 2, they marked for us, I'm going to go ahead and color them in, angle V and angle Y. That means these are 2 congruent angles, or congruent to each other. But in order for it to be similar triangles, I need to prove one more set of congruent angles. And that's why I want to focus here. This should be something similar. We've seen this in semester 1 with angle X there. When angles are across from each other, I really hope we remember vertical angles. We used them a lot last semester. So vertical angles are always congruent. So I do have a second set of congruent angles here. Even though it wasn't labeled, I need to use that knowledge of vertical angles to do this. With that being said, since I do have 2 sets of congruent angles, I do have similar triangles. So again, I'm going to start by naming the first one. I always start with the left side. So why not VWX? Remember, the first one really doesn't matter, but I have to follow my pattern. So I started with a V with my 1 mark. That was my first one. My second one has no mark, and my third angle has the double mark. So I have to follow that pattern, which means Y would be first because it has 1 mark, Z would be second because it has no mark, X would be last because it has the 3 mark. Just following that pattern I established in my first triangle naming. So again, it's not the only way you can name it. We can do it multiple ways, really. Let's say we start with W this time, and then go to X, and then go to V. W had no label. Z also has no label. X had the double mark, so X with a double mark again. V had the single mark. Y has a single mark. That's how I'm doing it. You don't have to do it multiple times. I'm just showing you that you guys have different options or different ways of naming. Just because I name it one way, but you name it a different, you could also still be right, okay? So don't freak out if you're using a different letter pattern than I am. Okay, so that's angles, right? 2 sets have to be congruent. Now I'm going to talk about sides. If we're given all 3 sides, what we have to do is that they all have to be proportional. So the way I do this is I'm going to build fractions. In number 3, I'm going to start with my shortest one, and that's a 3. And I'm going to put that fraction with the shortest one from the right, which is 6. 3 over 6 is really just 1/2. Then I'm going to go with my my medium leg, I guess. My middle number in this case is 4 on the left. It's not the biggest, it's not the smallest. Medium number on the right is the 8. So I get 4 over 8, which is also 1/2. I do have to compare the last set of sides. Longest side is 5 on the left, longest side on the right is 10. And I get 1/2. So each fraction came down to being 1/2. So yes, I do have similar triangles. And again, in case you're confused as to why I did these fractions, 3 and 6 were the smallest sides in their triangles. 4 and 8 were both the medium sides, and 5 and 10 were the longest sides. That's why I partnered them up. So since all my fractions came out to 1/2, I do have similar triangles, so I can say triangle QRP, why not, is similar to. Notice QR was my longest side, and then I turned and went over my medium side. So I have to do that pattern. Go down my longest side and go over on my medium. So in this case, it has to be TUS. Like I've said, there's more than one way to name these as long as you stay consistent in your pattern. So we could also say triangle PQR is similar to triangle. So notice PQ, my shortest, and then my longest. So the shortest is ST, and the longest is TDU. Again, you don't always have to provide 2 statements. I'm just giving you 2 so that you can see that there's not one set way to name these. Let's look at number 4. We since they're all sides, we just need to build 3 fractions. So on the left, my smallest number is 30. So 30. My smallest number on the right is 24. My medium number on the left is 32. The medium side on the right is 25. Longest on the left is 35. Longest on the right is 28. Okay, so now what we're going to do, we are going to simplify these fractions to see if these are all proportional. 30 over 24, well, I know what, 6 can go into both of these, right? 30 divided by 6 is 5, and 24 divided by 6 is 4. Okay, now we're looking at 32 and 25. Let's see here. Why can't I think of what can go into those? And that's because I believe it does not really simplify down to anything. Like 32 is even, 25 is not even, so no 2 can't go into them. 3 can't go into both of them. 4 can't go into both of them. 5 can't go into both of them. Neither 6 nor 7. 8, 9, or 10. So honestly, there's nothing we can simplify this one down to. It's going to stay 32 over 25. And I'm going to go to the last one, which is 35 over 28. 7 can go into both of those, and that will become 5/4. So notice the first one goes to 5/4, the last one went to 5/4, but this middle fraction, it doesn't simplify down to it doesn't simplify down to anything. So since I don't get 5/4 in the end, this one is a not similar. I do have to have that same fraction every time. So since that 32 over 25 messed us up, these are not similar triangles, okay? Okay, lastly, the side angle side. What this means is there's always two sides that will be labeled and the angle that those two sides make. Notice, this side is labeled and this side is labeled, so JK and LK, and they both make angle K, and angle K is the marked angle. Same here, MN is labeled, PN is labeled, the angle they make is labeled. And that's what has to happen. The two sides, the angle that gets marked has to be the one that the two sides make. If, for example, they had labeled angle J instead of angle K, my two labeled sides do not make angle J. So then I couldn't use this, okay? It has to be that angle that gets made by my labeled sides. So the only numbers I have are the sides, which I will make two fractions. Smallest side on the left is 8. Smallest side on the right is 6, which leaves 20 and 15. Where'd my 2 go? There we go. 8 over 6, when we divide by 2, gets me 4/3. And 20 over 15, when I divide by 5, will get me 4/3. So since my two fractions match, the angles that are getting labeled are the ones that are made by the labeled sides. I have similar triangles. So I can say triangle JKL is similar to triangle. I started with side JK, which is the shortest. So I start with the shortest from the other, which is MN. And then that leaves me P. It's the last letter to use. Could I say triangle, where am I? LKJ? Why not? If that's the case, I did LK, which is the longest side, so then I have to do PN, and then that leaves me MTUs. So you need to pay attention to your order, how you're naming these based off the picture, and just follow your patterns, okay? Last but not least, number 6. This one's going to be a more confusing one. I've noticed that the picture within the picture messes us up, so I will be coloring these. So we have the big triangle. Oops, that's a 12. And then the little one within it, so that we can pay attention to what we're doing. They both have an angle A, right? Green triangle has the angle A. The blue triangle has the angle A. So we're good. We have an angle. It's not marked, but I know they share it, so I can use it. Got to build some fractions. So biggest side for the blue is 25. Biggest for green is 15. Biggest for blue is 21. Biggest for green is 12. When I divide 25 and 15 by 5, I get 5/3. When I divide 21 and 12, I can divide them both by 3. I get 7/4. Those are not the same fractions. Even though I do have an angle set, those two sides are not proportional. So this one is not similar. So in this case, I wouldn't name triangles because I don't have similar ones to name. If you guys feel confident in trying this, you're going to move on to page 9. If you want to stay on this video, I am going to go over a few questions from page 9 that I think you might just get a little confused on. But if you're ready to go ahead, you can go ahead and stop this video and start your practice. Okay, so page 9, first question I want to go over is number 4. So number 4, we have a triangle that looks like this, but then there's a triangle inside of it. R, Q, X, Y, and P. I have a 5, I have a 15, 16, 12, 6, and 18. Okay, this one I just wanted to make sure I went over because across the board we've been intimidated by the triangle within a triangle stuff. So I have this big blue one, and I have the small green one also. So I will tell you, this one has two different approaches because they share angle P. If you want, you can use side, angle, side. But all sides are labeled, so you could also use side, 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 okay? It's up to you on which one you want to use, because in the directions it does say state which one you are using. So on this one, technically you can use the two different ones. It's just whatever you label. So please be wary of that. I will leave you to do the computations, but I did want to give you that big hint. I also wanted to look at number 5 because I'm thinking we might not remember some of the information from number 5. Okay, so we got... And we've got a bunch of arrowheads. So remember, arrowheads mean they're parallel. So this one is parallel with this one. And I'm putting 2 on this one because it's parallel with this one. We'll start putting our letters in. Okay. J, N, and M. So something I think we might have forgotten from last semester is when we took the notes on this stuff, the 2 parallel lines in the transversal. Remember, we knew that these 2 were the congruent, these 2 could be congruent. A lot of different relationships we learned from that. So that is what we're going to implement here. So what I'm going to do, I'm just going to go over some matching sides. So for example, this KM and JN are both parallel. And they both have this guy going through it. So I just want to focus on the blue. Because again, it kind of looks like that picture I just drew, right? So with that being said, if I'm just looking at the blue, I can say that this angle right here would be congruent to this angle right here because we have corresponding angles. Remember, if I were to cut that in half, angle K and angle J would overlap each other. Okay, so now I'm going to not do that. I'm going to erase these blues. Put their sides back in though. And now I'm going to do blue on the double arrowed sides. So KN, oops, I lost that. Lost my little markings. And LM. Okay. So with this one, using that same logic of corresponding angles, I do have a set of corresponding angles over here at angle L and like the bottom of angle K. Okay. Again, corresponding angles. So now on this one, please be aware. So you are using angle, angle, right? There's no sides labeled with numbers, so this one can't be a side one. So this one is angle, angle, similarity. So when you name these triangles, order will matter. So it just depends where you start. You can start with the top triangle, end with the bottom, start with the bottom, end with the top, doesn't matter. Please follow a pattern based off markings. Angle J has a single marking, so please pay attention to that. Angle K, depending where you are, has a double or a single, so please pay attention to that as well. If you're using angle K from the bottom, it means something different in the top. Angles M and N have no markings, but then angle L has a marking. So all your markings are on that left side of that picture. So please be cautious on your naming. If you're unsure about any of your namings, please call me over. I will check it, and we can talk about it if you're stuck.